Right, the door's shut, we're locked in. 30 minutes, no escape. Let's see if I can keep you awake. My name's Lee Beard. I lead the UK and Ireland public sector team for BlackBerry. And today I'm going to be talking about our AI model, principally, and how that can help you in a cyber context, but also environmentally as well. A little bit about ourselves. I'll get the elephant in the room out of the way. We don't make phones anymore. We haven't done that for 10 years, but it's one of the most common questions I get asked almost every day. What happened to the phones? Well, what you see on the screen there is just the metal, plastic, glass that constituted the phone. The intelligence, the end-to-end encryption, secure messaging, all of that is still around. And add to that our acquisition of Cylance and the AI capability there, we've got a really strong, compelling message into the market in terms of looking after you from a cyber context, both on-premise, off-premise, for IT, in the cloud, operational technology, and also in embedded instances. We look after around 220 million electric vehicles out there. We work with 25 out of the 26 electric vehicle manufacturers to keep their systems safe. So we've been busy. And the clicker's stopped. So, as I said, I'm between you and lunch, so I'm going to do a little bit of audience participation. I did have a nightmare this morning of only 2 people being in the room, which would have killed this bit, but let's see where we go. Just a show of hands, in terms of using a search engine today, who uses Google? Okay, and who uses another, like Bing? Okay, we're going to come back to that a little bit later, but have a think about your choice and why you came up with that. So my background is in sales into secure government, specifically intelligence and military. And everything we do at BlackBerry, I'm sure you've heard the expression shift left. Our view on that is kind of left of bang. Now this is a concept that was kind of brought to my attention a few years ago when we were in conflict in Afghanistan, and there was a lot of furore in the press about supply chain and things like ammunition, but more importantly, things like armour not getting to our troops. And I was talking to a colonel at the time who said, well, if you've got information superiority, if you know more than your adversary, then you just stay out of harm's way. And then the amount of bullets and the amount of armour is actually less pressing. So that's our concept, left of bang rather than right of bang. We don't want a patient zero. We don't want the first soldier to get wounded to understand that we're in trouble. So that will make sense.
Prevention rather than?
100%. So today, the way we use data, the way we interact with our devices, that's changing. And so we've got to evolve and change. A lot of stuff out there is still operating on the same models that they've done for the last kind of 10, 15 years, signature-based. So, in terms of we need a patient zero to then triage, to then come up with a signature, to then publish it, for that to be put into your repositories, tested, and then released. And this cycle happens over and over again, as it shows on the slide. So we're working in the context of a model of knowns, known malware, known attack techniques, even known attackers. And this requires vendors to collect samples and IOCs that come from the victims of the first attack. Again, right of bang rather than left of bang. Patient zero, we need that to be triaged. So when these kind of rules have been built and signatures have been built, they then become your problem, again, to test, to roll out, just so that you can solve yesterday's attack, yesterday's method of attack, rather than the prevention of an attack today or even tomorrow. So we're going to look at how BlackBerry approached this when the slide moves. Okay, audience participation section 2. Can anybody tell me what that is? A giraffe. Okay, well spotted. So our brain is brilliant at establishing what something is with just a set of small features. We don't necessarily need to know the whole picture. So if you go back to your youth, a parent or a teacher would have shown you a picture of the giraffe and broken down the features for you. So the long neck, the unique coat pattern, the long legs, shape of the head, the horns, all of that good stuff. So next time you saw a picture of a giraffe or a bit of a giraffe, you knew that it was a giraffe. This is really what we do with our AI model in terms of breaking down, understanding features and being able to spot those features. So just like the features of the giraffe, portable executable files all have their own sets of features. They have titles, they have banners, they have tables of contents, they have millions of features, as well as all the metadata. It's so much information that us as just ordinary humans wouldn't be able to break it down and understand it and do something about it without some help. So that's what we do. If you've got dozens or hundreds or thousands or millions of these files, as most systems do, identifying a bad file from a good file is actually really, really tricky. If we go back to our giraffe, how would you know if that giraffe had a genetic issue? Unless it had a different coloured coat and it was really, really obvious, it's really difficult. You'd need to be a vet or a biologist, and even then, you'd need to employ techniques like X-rays, scans, blood tests, or even a DNA analysis. So if you think about DNA analysis, now we're getting somewhere. That's kind of what we're doing here in terms of the breaking down of these files, so that we can take a look at the features and understand the good from the bad. So that's what we do with the executable files. We dig into the DNA and look into millions and millions of characteristics and features of a file to determine whether it's good or bad. So our algorithm has learned how to do this by studying, I think we're up to something like 1.4 trillion features now. So understand, break down, build the algorithm up, and then every time we look at something, we compare it to the algorithm and understand whether it's a good or a bad file and make a prediction. So this, again, is all of the left of bang stuff. And if you think about, once we've extracted all the features and broken them down, we only actually retain, it sounds like a big number, really contextually it's not, the top 100 or 200 million features. The rest of it we just discard, because those tend to be common features found in all code, in all software. If you think about the way that people write code, either legitimate software code or malware today, they reuse most of it. We're only looking at subtle differences. So that's why the model is very lean and very quick. A good kind of paradigm for that, I guess, or a good example for that would be, again, going back to a more kind of medical-based analogy. If you think about our own fight in the pandemic against COVID-19, the real neat trick was in understanding the genetic makeup of COVID-19, the first round. And going back to then things like Delta and Omicron, the research and development cycles and the issue cycles were much, much quicker because we only had to look for the differences. So what do we need? We need 4 things. We need tons and tons and tons of data. And we've been in the field since 2012 collecting that data. We've got access to probably the world's biggest repository and other online repositories in terms of understanding the binaries and the DNAs. Hello. You've missed out on the giraffe, but don't worry, we'll get back to the giraffe. Where was I? Sorry. A whole load of data. So again, going back to the giraffe analogy, if you're doing a DNA analysis, imagine the billions and billions of strands of DNA that you've got to kind of collect to make some kind of analysis. We then do feature engineering, understanding what all of those different things mean, what they do, what they're likely to do, and then grouping them together so that we can start to make a prediction via the model, which is next in the sequence. So the predictive model, its job is to take a look and make a prediction based on features that it's found in comparison to the algorithm, and make a prediction on whether something's going to be good or bad in milliseconds. And then we create labels. So we've got something useful to reference to in the future. I'll make a simple example. It's good, let's call it green. It's bad, let's call it red and put a skull and crossbones on it. We're probably more likely to use something more helpful, like keylogger or virus, that kind of thing. But we label so that the predictive model's job is much quicker and much easier next time. Everybody with me on AI so far? Good.
Yes, I've got a question. It's okay. I'm interested where the boundary is of what constitutes execution code. I mean, for instance, if it sees script that is not yet binary, but could become binary, is that counted as execution, or is this really just binary?
No. It includes script control as well. Any other questions while we're pausing?
It's a similar question, but is it just limited to executable code in its widest definition, or could it just be used for document classification, loss prevention, for example? Because it seems the same model.
Yeah. So we have a product called, I was told not to get into products, but we do have a DLP solution that that classifies products, documents rather, using the same model. Which brings us neatly onto the next slide. I'm not going to go through this in detail because this is a producty slide, and if you want to know more about the products, then by all means catch me after this talk or come and see us on the stand and we can take you through that. But in terms of AI, that underpins everything we do, pre-execution of malware, pre-execution of code, left of bang, stay safe rather than triage and repair afterwards. Okay, and that underpins everything we do that you can see on that slide. Click, click. Sorry about these build slides. So the output of that, 99% plus efficacy against malware. I know it says 100% on there. Nobody's got 100%. The reason it's on there, SE Labs did a test recently and we came out with 100% efficacy and no false positives. So that was too good not to put on there, to be honest. It's simple to set up. There's no real learning and engineering period, behavioral period, as there would be in kind of traditional remedies. It's predictive. Again, left to bang, it does all of that for you. So it's literally drop on and go. And the real thing, I guess, the pivot point of this kind of talk between how we do it and some of the benefits is in performance. And this is the fact that it's really, really low power drain on CPU, lowest in the industry, in fact. So if you think about what that might be doing for you, I've worked into a number of organizations where, if you're putting in a security product, there's a deprecation of performance on the laptop or the handheld, and that can create issues. You can lose productivity minutes. If you've got, as I've seen in some organizations, a culture of engineering and we'll just get things done, then people start working on workarounds, maybe switching things off, which completely deprecates the model in any case and destroys the ROI. Another medical analogy here, first do no harm. That's the principle that kind of underpins this in terms of safeguarding data integrity, productivity, budget control. All of those start from the basis of don't make the computer worse. Have us do our thing, have us protect the system, device, server, whatever we're protecting without taking any performance away from it.
Where's the knowledge base sitting? It's not sitting on premise then, is it sitting, or is it?
It's cloud-based.
This does require some sort of connectivity, whether periodic or...
Not necessarily. Periodic, yes. So it'll work completely offline.
Yeah. But presumably the offline, it's always the case that if something happens between your periodic offline, the database may actually know something you haven't picked yet. That might be infinitesimally small.
Yeah, indeed. We have a number of different kind of ways around that. If you're if you've got an offline requirement, it tends to update only once or twice a year. But we've also got a virtual instance that will fit on a USB key that you can just plug in and scan and test. So you don't even have to connect to the cloud or the internet. That one's fairly new, by the way. But yeah, again, if you want to know more, come and talk to me. So I guess to corroborate all of this, we had a report commissioned. And I'm going to apologise in advance on the basis that it's a little bit kind of washing powder advert. So we've got brand X, brand Y, and us. But it bears out the model. So we did 4 tests on this, and these were done on a kind of low resource, medium resource, high resource device. So just a resource consumption test. So when the program is idle, what resources is it using? Benign files really covers the impact of loading chunks of 500 files at a time onto the disk. Malware detection and cleaning when it's at work and doing what it needs to do, and also just overall CPU usage. And this is what the test came out with. So brand X is yellow, brand Y is red, and we're green. So as you can see, the biggest differential we see here is in CPU usage. Massive difference. So again, if we're getting into the realms of productivity, minimizing lost minutes, minimizing, all of this stuff saves electricity, by the way. So if we think about the current cost of living crisis, your FDs and your facilities managers will all be quite interested in some of the output from this. So the graphic that you see on the left is I'm going to call it a noddy calculation. It's not my sums. This comes from the US Department of Labour, and I would invite you to do your own calculations here in terms of potential ROI and the value of lost time in your own organisations. Where this is basically saying 10 minutes per worker per day loss could run up to tens of thousands per year in a small to medium enterprise. On the right-hand side, the scales represent tests that Microsoft did, actually, on one of their Surface machines, a kind of mid-range touchscreen laptop. And they came out with a good carbon calculation. It's all right doing the financial sums, but we're here to talk about the environment as well. So what you can see there is a vast majority of the carbon that comes along with producing and using a device is actually in manufacture. That's around a 78% balance there out of the 152 kilograms per device. So what people have found by using this lightweight agent, because it doesn't deprecate the CPU to the same extent as other solutions, they can push out their triggers for refresh and recycle for anything between 12 and 24 months. So again, I would invite you to do your own calculations with regards to how many devices you've got, how many grams of carbon you can save per device per year by pushing the refresh cycle out. There's loads of carbon calculation, carbon calculator tools online that you can use to do that as well. So, whether you're eating your own dog food, I really don't like that expression, or drinking your own champagne, that's better, or we're in Scotland, having a nip on your own whiskey, sorry, couldn't resist. Credibility is really, really key. And I'm really proud to say that I work for a carbon zero organisation. And we made really, really brilliant strides with some good innovative partnerships around the globe. But like a lot of good ideas, most of this stuff has actually started at home. Transitioning from a hardware to a software organisation, actually using our own software, our own lightweight AI tools, use of our own solutions and partner solutions so that we can have a fully distributed workforce, means we've taken down real estate, reduced our carbon footprint that way, and work has become something that we do rather than somewhere that we go. And also, in terms of our own footprint in data centers, because the agent is so lightweight, you can get 20% more VMs per server. So again, your power drain and your footprint is greatly reduced. So that's what we've done. Don't take my word for it. We've done really, really well in the recent Cybersecurity Excellence Awards. I'm probably most proud of the fact that we've been called out as the best cybersecurity company, the best AI cybersecurity company. For me, they're one and the same thing, but also I'll take 2 awards over 1, thanks very much. We're good with that. So again, now that we've had a jog through, and it's pre-lunch, and I'm having a look, and I might have got away with this one because everyone seems to still be awake. Back to audience participation. So I asked for a show of hands right at the beginning of the talk in terms of who uses Google and who uses Bing. And the reason I did that, Google have been in the field since 98, 99 with their AI-driven search engine. Bing, 2009. That's a massive time advantage to build and grow your database, which feeds your algorithm. So when you go onto Google now and you type lasagna, it finishes the word before you've even typed it. It's accurate, it's quick.
But it does now give you 25 adverts before it gives you the answer.
I'm not going to confirm or deny or defend. But yeah, personally, I would use it over Bing. I find Bing a bit slow and a bit more.
Depends what you're searching for. If you do an image search, I would argue that actually Bing's got better technology.
Bing filters out all the Pinterest uses.
Well, but you're destroying my argument, so I'm going to move on.
But I would also say there's a whole bunch of other ones as well that are specialists for different things.
Anyhow, getting back to what I was talking about.
It's an interesting topic.
Oh, there's a sidebar here, and I'm not here to attack anybody, but in terms of the principles. So we've been in the field since 2012, building this model with trillion, I mentioned before, 1.4, 1.5 trillion features already mapped. We're the only organization out there that is 7th generation AI, pure AI, not a mixture of AI and signatures. And that's our advantage. That's our predictive advantage. That's it for the talk. Any questions?
Tell me. My name is Volodymyr.
I can just to talk a bit louder, I'll be able to hear you.
So my name is Volodymyr. I'm from Poland, Wrocław.
Okay.
And my question is that can you name like a top 3 biggest customer of BlackBerry right now?
Biggest customers?
Biggest customers.
I'm not going to name directly because that's a little bit corporate confidential, but we have all 7 of the G7 governments. We have, I think it's something like 23 out of the 25 world's biggest banks. So that'll give you an idea of the level at which we operate. And going back to the kind of embedded systems, 25 out of 26 of the electric vehicle manufacturers out there in the field today. Is that okay? Any other questions? Lunchtime then. Thank you, everybody. Thanks for your time and attention. Just going back to the report, there's going to be an updated independent report out in a couple of weeks. I was really, really hoping that I'd be able to bring you the data from that today. But if you're interested in learning more when that report's published, catch up with me now or come and see us on the stand. We'll take your details and we'll make sure that we get that in your hands. Okay. Thanks for your time, guys.